It's about 4:10, 25 minutes to sunset on a day where sunset is meaningless because it is totally overcast. This is typical mid-Atlantic weather in late fall. Luckily though, it's not that cold, keeping in line with the warmer winter that we're supposed to have. So that's nice. In this video, I thought I would expand upon the last. In the last video, I talked about Plato's forms, and I described what universals are, but I stopped there. I didn't actually give a direct opinion on my stance on universals, although I certainly did give indirect hints about where I stand on whether universals exist or not. Now, when people talk about whether universals exist, they frame it in essentially two ways. As a squirrel makes its way through the leaves, although it's very small and hidden now. One way in which universals is framed is the way I described in my previous video. That is, do properties exist outside of the things that hold those properties? The other way, or one of the other ways of framing the question of universals, is to say, how do two different things hold the same property? Now, if we think deeply about universals, we see that whether you believe in universals or not depends on your conception of what properties are. How you define what properties are. Now, in doing some reading on this topic, I am very unsatisfied with the way properties have been talked about by philosophers of the past. And I think this is because philosophers of the past have lacked the scientific knowledge that we have today. You can take a modernized position of properties and frame them in a mathematical sense and say something like properties or a property of something is a set of numbers which defines or represents that specific attribute of a thing or item. When we look at properties as a set of numbers, we can talk about the problem of universals in a way that I find satisfying. If we say, for example, that a property of something is defined by a set of numbers, then we can say that 1. Properties do not exist outside of the items which hold those properties. And secondly, we can say that 2 items or 2 things which are not identical can hold the same properties. Now, if we take the first claim, we can say that properties in themselves cannot exist outside of physical objects because those physical objects allow those properties or set of numbers to become physicalized. They allow that set of numbers to be measured and, in a sense, have meaning in the real world. Of course, numbers exist in the mind without measurement. But measurement is what gives numbers a place in the physical world. Without objects to be measured, numbers cannot be actualized or physicalized. If we take the second claim in regards to the problem of universals, where we say two different items can share the same properties, using the theory that properties are a set of numbers, we can see that this claim makes sense, because of course two items or two things can share the same set of numbers which represent an attribute. Having two things which are representative or represented by the same set of numbers does not mean those two things are identical. They do not share the exact same number, for example. They just share a set or range of numbers which describe that attribute or property. Now, this scientific view I have of properties and how they can be applied to giving an answer to the problem of universals is not unique. Chemistry, for example, operates on the principle that properties of things are described in large part quantitatively by the quantities of things that are possessed within that substance. It kind of shocks me in a way that, at least in the philosophy I've read, that properties are not talked about in this scientific mathematical way. I think talking about properties in this scientific mathematical way gives great clarity to the problem of universals. And it also is very representative of reality. It is not some theoretical abstraction. And I believe that this gives even more weight to the idea that it can be used to give an answer to the problem of universals. I'm gonna put the camera down for a second because my body hurts and I need a rest. If we take, for example, color brown, we can apply the thought that the property of brownness is a entity which can be described as a set of numbers. Now, within the set of numbers that describes the color brown, there are segments of that number set which represent the many different shades of brown. Now, this division of a number set can be applied to any property as a way of giving a broad property more specificity. Say, for example, you wanted to distinguish light brown from dark brown. Light brown would be represented by a number set, let's call A, and dark brown would be represented by a number set called B. If you wanted to get more specific, you could break it down even more. Now, to understand what I mean when I say properties are number sets, you have to have an appreciation for the way scientists have learned to break down the world. If we were to take an easy example, we may look at the spectra of visible light, for example. Now, each color is distinguished from the other via its wavelength. Each color has a different wavelength. In this way, chemists and physicists are able to give an object the, let's say, property of having a specific color. When philosophers talk about properties, they essentially like to just name a noun and then put ness at the end of it. So, let's say roundness or redness or chairness or anything like that. But ultimately, what they are doing, and perhaps not realizing what they are doing, is fundamentally describing a set of numbers which are representative of the object they're talking about. Now, I understand that this idea will go over some people's heads, but ultimately, I feel like a lot of philosophy goes above people's heads. So, it is fitting in that sense. As a plane flies by through the clouds, you can hear it. The idea that all properties are represented by a set of numbers would also explain why there's so much complexity and so much variety to the universe. there is no limit on how far we can count. So, in a sense, you're operating in a playing field of infinite possibilities. In such a scenario, all the amazing complexity you see around us makes much more sense. But also makes sense to say that the universe uses this infinite counting ability as a possibility generator, which I contend is the case. In my previous videos, or video, where I talked about Plato's forms and described the problem of universals very briefly, I had the sense that universals did not exist. But I did not have a sufficient thought to back up that feeling. But I hope this video did a good job of describing the thought that I have come up with. In answering the question, and saying, no, universals do not exist, and also explaining to a satisfactory degree what properties are and how that conception can lead to an answer as to the problem of universals. It seems like everything in philosophy comes down to how one defines and comes to justify their definition of key terms. If one can come up with a satisfactorily justifiable definition for a key term, in this example, what a property is, they are well on their way to understanding the world and being able to articulate that position to people. And with that, as the light fades and the gray becomes more pronounced, I will end the video and get some rest, because I do not feel like I am breathing that well. But I feel like today's effort was well placed, and I'm happy with the product and the work put in.